You remember last time that we were looking at how we can use a variable like index to work our way through a list to search for a specific item. So let's say we were searching for Edgar. We stored Edgar in our search variable, and then we made index move from 0 to 1 to 2 to 3 to 4 to 5 and so on. But what we did in the end is, if you've had a look at my solution video, you'll have seen that the index, when it gets to 4, it will stop. So we know that Edgar is at position 4. So it's taken us 1, 2, 3, 4, 5 comparisons to find Edgar in our list. Now obviously, if the list is a very long list, and there are very large databases in the world, then that's going to take a long time. Is there a more efficient way of searching for Edgar? Well, you might have noticed when you look at this list that it's organised differently from the last time that we did it. I've put them in alphabetical order. Now, if the list is in order, that means we can start to use a different strategy to find Edgar in the list. It took 5 comparisons to find Edgar before, but let's see if there's a better way of finding him. Let's take our index, and we could start somewhere different. We don't have to start at 0. What we could do is we could start at the middle of the list, here. We could check here and we could say, is Edgar higher in the alphabet or earlier in the alphabet compared to what we find here? And if we find that it's higher or lower in the alphabet, then we can remove that whole part of the alphabet. So let's think about how many comparisons we'll have to do to find Edgar. We'll compare the middle of the list. We find Dennis. Is Edgar further on in the list or earlier in the list than Dennis? He's further on in the list, isn't he? If he's further on in the list than Dennis, we can say straight away that none of these will be in it, and we can take all of these out of the equation. Now we go to the middle of the list again, and we check at that point. Is this Edgar? No, it's not. It's Frida. And we say, is Edgar lower in the list or higher in the list? Clearly, Edgar is lower in the list. So now we can take out all of these. All we're left with now is one item. Is this Edgar? Yes, it is. And so we can do that. And you notice that we've only had to do 3 comparisons, whereas before we had to use 5. And in fact, 3 is the maximum number of comparisons we would have to do in this list to find any specific person. Now, one variable isn't going to be enough, because we need to know where the start of the list is and the end of the list that we're working on. So what we're going to do, we're going to introduce 2 more variables. We're going to put one at the front of the list and one at the back of the list. So in our algorithm, we're going to set front to be 0 and back to be the end of the list, which is position 6. Now, how can we find the center point of the list? Well, if we think about it, 3 is half of 6. So if we add the front to the back and then halve it, we'll find the middle position. So what we're going to do is we're going to make a new variable, and we're going to call that variable mid for middle. So mid, think about your bid mass now. Bid is front plus back divided by 2. Now, you've got to be careful with Python because Python likes to turn this into a decimal number. So we're going to make it into an integer, a whole number, to make sure everything stays as integers. So we're going to start here and we're going to say, right, front is 0, back is 6. What will mid be? Front plus back, 0 plus 6 makes 6, divided by 2 is 3. So mid becomes 3. Okay, so we're going to check, is the item at that position in the list the same as what we're searching for? So it's very similar to what we did the other day. In this case, we're going to say if names which position are we looking at? We're looking at position mid. Is that the same as what we're searching for? Getting a bit small here, getting a bit too tight at the end there. So is names at position mid the same as search? Now, if it is, that's fine. We can print that we found it. Perfect. But what are we going to do if it's not? Well, what we can do is there are 2 positions now we can take. It's either bigger or it's smaller. So let's take both of those situations. So if names mid, so whatever the name is at that position mid is bigger than search. So let's think here. So if names mid is bigger than search, so if Dennis was to be bigger than what we're looking for, we know that what we're looking for must be down there, must be in that area there. And the easiest way of making it fit that area there is to move the back variable to 1 less than mid. So if names mid is less than search, then we will make back equal mid minus 1. So we've got what happens if it's equal to, we've got what happens if it's more than. Let's see what happens if it's less than. So if the name we find is less than what we're searching for, so let's think, in this case that's right, isn't it? The name we've found, which is Dennis, is less than what we're looking for, further lower down the alphabet than Edgar, which is what we're looking for. Then again, the easiest thing to do here is to move front up. So front becomes 1 more than mid. Now all we've got to do is to make sure that that keeps repeating over and over again. Now can you remember what it is we use to repeat something? Yes, we're going to use a while loop. Now, how are we going to make that? Keep going round and round? What are we going to check for? Well, let's think about what might happen if what we're looking for is found. So we've got to mid there. Mid has moved to here. That's not there. So back will move to here. Mid will now become here. Now, if that wasn't the case, then we'd probably find that mid or back will move in front and so on. So what we'll do is, we'll say as long as front is smaller than back. What that means is, as long as we never get to a point where front goes behind back, if that was to happen, as long as front is less than back, or less than or equal to back, I think we should say, then we'll be fine, we can keep going. If front ever gets bigger than back, then we know that we've gone too far and it's time to stop. Try that out in Python for yourself, see if you can make it work, and see what happens when you try it with different names there. And what happens if you try a name that isn't in the list?